Like, let's just see how many people are using GitOps now. Okay, cool. So one of the pain points is managing secrets, obviously, right? Because obviously secrets are sensitive, and then you have a bunch of teams working together, so you need to make sure who has access to what secrets, right? So that's what basically we'll be covering today. I'll just go through the agenda. We'll talk about what GitOps is, how kind of people use it, then what are the limitations behind shipping your secrets via GitOps model, and then we'll talk about the possible solution, which is OpenSecrecy, right? Okay, so GitOps in layman terms, it basically says your source of truth is your version control system. It doesn't need to be GitHub. You can use GitLab, anything, right? So it's just that your source of truth has to be your version control system. Now there are benefits. Obviously, there are a bit cons as well. But the benefits, obviously, you get version control, so you have total control over what you are shipping to your production servers. Consistency, since you are using your version control system as your source of truth, you can totally stay consistent with whatever you are shipping with. You have 100% guarantee that, okay, hey, what is there in the repository, that is what is deployed on my production servers. So that makes, an SRE's job is a bit easier, because when the time comes, you need to jump around things, and this is just one less thing to worry about, because you know what is there actually running on production. Automation, obviously, right? So whenever you want to do production rollouts, in GitOps usually people will make a PR to your whatever repository you are using, and then whatever mechanism, right? It can be Argo CD, it can be Flux CD, whatever you are using, you can just merge that PR and your application gets deployed. Effective collaboration, right? So let's talk about secrets, right? So let's just say I spun up a database, I have some secrets, and now I want to share it with someone, right? The application needs to utilize those secrets. Now, when it comes to collaboration, most of the times there would be multiple people working on it, and then when you are trying to kind of review someone's PR and all these things, GitOps makes it kind of easier for people to not have downtime, because multiple people are actually checking out your PR, providing you feedback, what should be shipped, what should not be shipped. So yeah. Then why secret management matters in this case, right? So obviously secrets host your sensitive information. So they typically will be your API keys, your passwords, your database credentials, etc., right? The list goes on and on. Now, when using secrets, like when shipping secrets in GitOps fashion, right? We can't just really store the secrets in plain text in your repositories. That's not how it works, right? Like, that's not how you're supposed to do. That's basically a very insecure way, irrespective of your repositories are private or not. We'll talk about it later as well in terms of a platform perspective. But yeah, then the data protection, right? So secrets basically, they safeguard your things, right? Your database password will be the safeguarding mechanism in front of your database. That's how your applications or users will authenticate and authorize themselves. And then authentication, obviously. Many services rely on your secrets to basically kind of authenticate themselves, authenticate incoming requests, and things like that. So yeah, it's kind of a tricky to get everything pieced together when it comes to shipping your secrets via GitOps way. But OpenSecrecy is aiming to kind of solve it. So yeah, challenges in managing, right? So yeah, insecure. So basically, when you store your secrets in a repository which are in plain text, they are totally insecure, right? Irrespective your repositories are private or not, you're hosting some private GitLab instance which is not open to internet, it doesn't matter. As long as people have access to those repositories, they can go and check in the secrets. Then decryption, right? Even if we encrypt these secrets, how these will get decrypted, right? So basically, let's say There are a bunch of tools available, like one of the popular one is GetCrypt. Basically, you encrypt your stuff and store it in a Git repository. When it comes to external secrets, it's just matter of me adding some paths to the secret config, and then the external secrets will pull out those secrets. Pretty easy. Then in terms of Kubesil is a one-way encryption mechanism. So basically, whenever you encrypt it, once the secret is encrypted, you can't basically decrypt it in a simple way. Obviously, you have some disaster recovery CLIs which you can use to decrypt your secrets, but that's for disaster recovery, right? That's not for your PR reviews and stuff. Just an example, I'm someone, I updated a database secret, I had to rotate it, I updated the secret, and now I need someone to review the PR. Let's say my PR is reviewing the PR. Since the secret is one-way encrypted, he can just say, okay, this looks good or bad. He can't actually verify what I have written as a secret, right? So there might be a case where I made a human error, I made a typo in the password or something like that, and then since the person who was supposed to review the PR, he couldn't review it because Kubesil doesn't allow you to do that, the secret will go in production which had an incorrect value, right? So that's pretty bad scenario, to be honest. Rarely happens, but obviously we are all humans, right? We are bound to make human errors. Then encryption and decryption, right? So again, external secret doesn't have a kind of an encryption mechanism. Obviously, you can use Kubernetes feature like encrypt at rest so that you can have some secrets config in Kubernetes, but yeah. Otherwise, it relies on your third-party system to be stored or to be, have encrypted secrets. So by default, it doesn't have any encryption mechanism. Kubesil, on the other hand, as I said, it handles encryption on its own, but it's a one-way encryption. Once the secret is encrypted, the user can't decrypt it. Only the Kubesil operator can decrypt it. So I'll show what is the pain behind that approach as well, and then the flexibility. Right, so external secrets is very popular project. So there are a bunch of providers available in external secrets. So you can just use them as your secret store, and then just go ahead and use external secrets. In terms of Kubesil, it is a bit limited because it doesn't rely on external systems. So all it does is it gives you an encryption key. It doesn't give you an encryption key, but it has an encryption key which the Kubesil operator uses to encrypt your secrets, and then decrypt them again when you apply the manifest, and store them in a Kubernetes secret. Now, solution for this, right? So that's what OpenSecrecy tries to solve. So OpenSecrecy basically has two components. One is Cryptctl. It is basically your CLI tool which your users, developers, or whoever is working on it, they will use to kind of create or edit your encrypted secrets. And then there is an encrypted secrets operator as well, which kind of plays the important role because the operator is the one which will be reconciling your encrypted secrets objects. So whenever there is a change in encrypted secret, the object will be responsible for reconciling the secret, decrypting the encrypted value which is coming from your Git repository, and then storing it as a Kubernetes secret. So yeah. So now features. OpenSecrecy has effortless encryption, as in by default you have your standard encryption key which will be stored in your Kubernetes cluster, so that you can have RBAC on top of it and get the job done. Now since it is written in a way where you can have multiple providers, so you don't actually have to use Kubernetes as a provider. So you can use AWS KMS, so that your secrets will be encrypted using the KMS key, not the key which is stored in your Kubernetes cluster. Then simplified management. Since the secrets are encrypted, obviously they can be stored in your Git repository. You don't have to worry about them being leaked or what. Now namespace encryption key. So this is one of the main point which Kubesil doesn't have right now. Namespace encryption keys basically allows you to take advantage of the multi-tenant nature of Kubernetes, right? When you are working as a platform team and you are hosting multiple developer teams together, you would want to restrict the team's access to their namespace only, right? So for example, what kubectl does, it gives you one encryption key, and then whatever team is using kubectl, they'll be basically able to use the encrypted secret manifest in kubectl to get that secrets in their Kubernetes cluster. Now, since the encryption key is only one, you can't really, have RBAC over it. You can't just say, okay, these guys belong to this particular namespace, like this guy's application is being deployed in a particular namespace, so only this namespace will be using these encrypted secrets. You can't do that. But since encrypted secrets operator has a feature for namespace encryption keys, your encryption key will be stored in the particular namespace. When I'll show you a demo, I'll cover that as well. Then, as I said, multiple providers support. So Cryptctl basically allows you to multiple providers. One I talked about is your Kubernetes. So you can use Kubernetes as a provider. What it does is it generates a random certificate which is then used as an encryption key, and the encryption mechanism is your standard AES-GCM encryption algorithm, which is what Kubernetes also uses when you enable, the flag which allows you to host your secrets and encrypt them at rest. Basically, Kubernetes has this feature behind the flag, which kind of allows you to encrypt your secrets, config maps, and all these things when they are getting stored in etcd. So that's called secret at rest. So this kind of uses the same algorithm. Then client-side decryption support. As I said, right, when you're working with multiple teams, right, let's say for example I'm an SRE, I work with multiple teams. Now in this case, when there is a request like, hey, my kubectl secret is not being shipped properly, I need to go and check in the cluster, okay, the secret is wrong. Then I need to come back, get the secret value, then encrypt it again so that I know the whatever the value which was encrypted before, that was incorrect, and now I have stored the correct value. Now when I make a PR, no one can actually review it again, right? Because kubectl can't decrypt the secrets. The users who are using kubectl, they won't be able to decrypt. Only the kubectl operator can decrypt. So this is a pain point behind kubectl which OpenSecrecy kind of solves. So you have client-side decryption support. Basically, you raise a PR. Whoever is reviewing the PR, he or she just needs to kind of pull the changes and just run Cryptctl edit, and decrypted YML will be rendered out, so that they can review the changes in real time. They don't have to rely on your system, on your operator to kind of decrypt them and then store them in a Kubernetes secret object, and then you verify the object. So it kind of shortens down your review cycle as well. You're less prone to make mistakes because multiple people are reviewing the changes, and easier auditing, right? The main GitOps advantage is the 3 W's, right? Who, when, and why. Since your secrets are in a Git repository, you have control over, like you can easily track who made the changes, when the changes were made, and why the changes made, right? Basically, if you know who made the changes, you can pretty much know why the changes were made. So yeah. So I do have a demo, but let's do it live. What's fun in having a recorded demo, right? Cool. So this is just my kind cluster. So let's say I'm trying to onboard a team, right? I hope. Yeah, so I'm trying to onboard a team. Let's create a namespace for that team, right? So the namespace for that team, it can be anything, right? Team 1, team 2, I just called it KCD. Now, all I need to do is Cryptctl create. So -f single.yml. So -f is for file. So whatever file name you want, you can give. -p is for provider. For now, I'll be using K8s as a provider. So as I said, you can use AWS KMS, or I'm working on adding some features so that you will be able to use whatever encryption providers are there, like GCPs and Azure. But yeah, for now only 2 are there. One is Kubernetes and another one is AWS. So once I do this, one secret will be created in that namespace. Okay, so now the file is created, right? Cryptctl create -f single.yml. Now what it will do, it will render out a encrypted secret manifest for you. So if I do cat, right, so this is the encrypted secret manifest. It doesn't have anything right now. There is no data into it because we haven't added any secrets, right? Now I need an encryption key which will be used to encrypt my data. So that I can create using Cryptctl init. Again, -n is case ready. Since we are taking advantage of Kubernetes RBAC, we can totally have namespace encryption keys so that I'm just creating an encryption key which will be only used for KCD namespace. So the same encryption key will not be used for any other namespace, and my provider is K8s. So when you use Kubernetes as a provider, obviously the key will be stored in your Kubernetes cluster, but when you are not using it, the namespace won't really matter, right? Because that goes outside the scope of your Kubernetes cluster, right? So when I run Cryptctl init, it will kind of create a key. So if I do K8s secret, you can see there is a key created called Cryptctl key. Now all I need to do is edit my encrypted secret object, right? So let's remove some here. So we don't need status right now. Right, so okay. Now since I did not give any namespace while creating the YAML, it is default, but you can change it back to KCD. Now I have a YAML which will host my encrypted secrets and the namespace would be KCD. So whatever I am doing, it would be tied to that particular namespace only. Now let's just edit this secret, right? When I run Cryptctl edit, if you see, okay. Let me open another tab. The object here was encrypted secret. If you see the kind, it is encrypted secret, but when I run Cryptctl edit on that particular object, the kind gets changed to decrypted secret. So basically, Cryptctl will talk to your Kubernetes operator. It will try to decrypt whatever you have, and then it will give you a rendered out YAML of a decrypted secret. Now all I need to do is add some data to it. Let's say secret1, right? Add KCD. When I save and exit, again, if you see now, there is a secret added, which is obviously this is not only base 64 encoded. When you encrypt something, that gets converted into a binary string, and you can't really store them here. So that's why there is a base 64 encoding happening. So let's just try to decode this, right? Cool. So this is the encrypted string, right? Pretty much unreadable. But since we need to store this in YAMLs and we don't want any validation errors and things like that, your encrypted string is again then converted to a base 64 value, and that is being stored. Now let's say I need to add another secret, right? So Cryptctl edit single.yml. See, now it again opened decrypted secret, and then your whatever secret you had which was encrypted before, that is now decrypted and it is being rendered in your text editor. So all you need to do is kind of, if you want to change this, you can change, or you can add another secret here. Let's just say secret 2. Right, again. So single.yml. Now it got encrypted again. This is what you can store in your Git repository because since these are encrypted, no one can really view them as is. Now since these are tied to KCD namespace, let's switch to a user. Now let's talk about a platform's perspective, right? I use an admin user, so it has access to all the namespaces. But when you are working as a platform team where you provide Kubernetes as a service to a bunch of teams, you would probably want to have a proper RBAC in place. That is, whatever is there in one namespace, that should not be, whoever is having access to one namespace, he or she need not have access to another namespace, right? So for example, in KCD, I created it with an admin user, so it basically has access to everything. But when I switch to a dev user, right, let's call it a dev user who has access to only dev namespace. So, right, so this is a dev user. So it doesn't have access to anything other than the dev namespace. Now, technically, what should happen when you use this kind of RBAC? Since your encryption key itself is stored in the particular namespace, right? For example, the YML which I created, it has the encryption key stored in the KCD namespace only. So dev user will not be able to get that secret, right? So when I run cryptctl edit now, you'll simply get an error, right? The user which you have used doesn't have access to the encryption key which was used to encrypt these secrets. And how this gets checked? One is the namespace. Obviously, when you use the user, the operator tries to, when reconciling, the operator knows which namespace the object has been applied to, and then the secret provider is K8s. So obviously it will look for the encryption key in your Kubernetes cluster. It will not go outside the cluster and things like that, right? So I use dev user, so I could not decrypt anything, right? So this kind of solves the main issue with kubectl which we have currently, right? Again, when you work as a platform team, you won't give access to multiple namespaces for a single team. Now I can just apply these changes, right? So let's switch back to the one. Okay, cool. Okay, apply single.yml. So the object is created. Now if I do k8s, I have the secret which was there, and then your application pretty much can mount this secret and use it as is. You don't have to worry about it being managed via some external system. So yeah. So now what's next for OpenSecrecy, right? So multi-object edit. So if you see, whenever this YML, right, this is a single object. So it has this is a single object for encrypted secret. But usually when people don't use Helm charts, they usually group together things. Like let's say I have a service. So for that service we'll have a deployment, we'll have a config map, we'll have a secret obviously, and then an actual Kubernetes service. People usually group together these things. So when, for the ease of management, right, when you group together these things, currently cryptctl doesn't support editing these group objects. It only kind of validates the encrypted secret object and it just ignores the rest of them. So I'm working on a feature where it will actually be able to render all the objects irrespective of what that object is. Basically, you can have all your objects in a single YML. Init container support. Now, if you see, there is a debate like are Kubernetes secret, like base 64 encoded secrets are safe or not? They are basically safe, but provided you have proper RBAC in place. If you don't have proper RBAC in place, anyone can come in and access the secrets in any namespace, then they are pretty useless, right? So some some use cases might not want to use Kubernetes secret objects. So that's where OpenSecrecy will have an init container support. Basically, you would just write whatever secret you want to mount in your deployment, and init container will decrypt the secrets and it will write them to your deployment spot where you can basically consume those secrets. So that's what init container would do. Helm chart, obviously. I don't have any Helm chart for it right now. It's just one Kubernetes manifest post, all your CRD and all these things. So Helm chart will be coming next, and then Windows support. Most of the people use Linux and Mac. It's there. The binary is getting built for Windows, but cryptctl doesn't really support it right now. The default editors and then default the rendering of manifest, right, which happened in the text editor when I ran cryptctl edit, that is a bit different in Linux and Mac than Windows. So it currently doesn't support it, but yeah, I'm working on it. So these are the repositories. There is an org called OpenSecrecy in GitHub. You can go and check it out. Yeah, if you want any feature or if you have any issue, I'm just a PR or an issue away. So do let me know. Do try it out and let me know what you think.
ready. So we need that to conduct the quiz. So if you folks can be ready with that, it would be quite helpful.
Okay, so this is the encrypted secret manifest, right? So if you see, all your secrets are encrypted here. I mean, this looks like base64 encoded string, but it is not actually. It is an encrypted secret which then is converted into a base64 value, base64 encoded value. So this is the YML. This you can store in any Git repo. You don't have to worry about what you are using, right? So for example, Argo CD is one of the popular projects. So when you store this YML in your Git repo, you can have Argo to sync this YML. So whenever there are changes being made to this YML and being pushed to the repository, Argo will kind of sync those changes and deploy them in your Kubernetes cluster.
I'll talk to you.
Yeah.
So, I mean, my question is, you are installing Kubectl as an API in the cluster, right? So all the developers has to access the API during the
no.
environment.
So they just need to install the Cryptctl CLI tool. Operator will be installed in only once. Then it's all Cryptctl.
Maybe, for example, I'm using it in a production environment. The secrets or API may be different. So I want to encrypt, use the same key so that it can be decrypted in the production environment. So
Okay.
all the developer needs to access the production API.
Okay, so if you want to use the same key, right, I mean that would not be recommended, but if you want to use same key, all you need to do is copy the secret. So basically Cryptctl encryption key, right, that is a namespace key, but you can totally copy it to another namespaces. Now, whenever the developer is trying to access a production cluster, first thing, he will need to have access to the cluster, and he will need to have access to whatever namespace he is trying to deploy the encrypted secrets. Like for example, I just showed there is a namespace called KCD, right? So whatever secrets I'm encrypting, they are being deployed in KCD namespace. So as long as the developer has access to this KCD namespace, all you need to do is run Cryptctl edit and he can just change the secrets.